Hey everyone! In this video, we're going to be looking at two examples of how to break vectors. So we have a question up here that says a duck flies 50 kilometers at 150 degrees from the x-axis. And we can kind of approximate where that vector would be at to look at. About 150 degrees is maybe-ish there. And what we need to realize is that 150 degrees from the x-axis is this counterclockwise rotation from 0 degrees. So that's our 150 degrees. And someone could have written this instead as north 60 degrees west, or maybe even have written it as 60 degrees west of north. And those are just different ways they could have represented this vector, but in the end, we are going to want to put it in this from the x-axis. From the x-axis. That is always our goal when we're breaking vectors, is to get it into some angle from the x-axis. I'm going to show you why. When we have it in an angle from the x-axis, we can have two equations. The first is that the x component of our vector is going to equal the magnitude of our vector, in this case the 50, multiplied by cos of theta. Now this theta has to be the theta from the x-axis. Our y component, the up-down component of our vector, is going to equal the magnitude of our vector, again, 50 kilometers, multiplied by the sine of theta. And we can go ahead and write this out so that our dx, our left-right component, is going to equal 50 cos 150 degrees. Which is going to equal negative 43.3 kilometers. Negative. But that's actually the really good power of solving components of vectors like this, because the negative just means going to the left. So we can write this broken vector as 43.3 kilometers west. The negative just means west. If this had worked out to be positive, we would know that it would be east. Same with our y components. If you get positive, that means north. If you get negative, that means south. We can fill in our dy, our y component of our vector, which is going to equal 50 sine 150 degrees. Again, dy equals 25 kilometers. Because this is a positive value, we can say that that is 25 kilometers north. This vector has now been broken. Let's go ahead. We're going to do one more example. Vectors are not limited to displacements or velocities. It's why I'm going to do an example here with a force. We can break any vector we like. We have a magnitude of 250 newtons. It's been provided to us 280 degrees from the x-axis. We can say that the x component of our force vector is equal to the magnitude of our force multiplied by cos theta. Remember that this theta must be from the x-axis. If you're dealing with norths and souths and easts and wests, you will have to convert. Our x component of our force is equal to 250 cos 280 degrees. The x component of our force is equal to 43.4 newtons. That's positive. That means it's up. This is a positive 43.4. So this would be in the north direction. The y component of our force is going to equal the magnitude of our force multiplied by sine theta. Fy is equal to 250 sine 280 degrees. The y component of our force is equal to negative 246.2 newtons, which means it's going to be pushing down. Our net forces show that we're going to have a force to the right, and we're going to have a force pushing down, and this vector as well has now been broken into components. I hope that you find this method helpful. It can be a lot easier than trying to draw different shaped triangles, as long as you have that standard angle, that 280 degrees from the x-axis, vectors can be broken very, very easily. Thanks for watching, and I hope to see everyone next time.